A consumer protection agency wants to prove that packages of post-grape nuts have a mean weight of less than 24 ounces. We want to use the following information to test this claim. Alpha is 0.05, N, our sample size is 100, our sample mean is 23.94, and our population standard deviation is 0.13. We are going to do a hypothesis test. Now let's note that this hypothesis test is for the mean. All right, so the first thing we do is we state our null hypothesis and we state our alternate. And here it may be easier to state the alternate first because the alternate is what is stated in our first sentence. This consumer protection agency wants to prove that the mean weight of these packages is less than 24 ounces. So they want to show that the mean is less than 24. Now, our null hypothesis is generally the status quo. We can think of it as it'll be the same as this, but always an equal sign. So our mean is 24. All right, and we'll see that all of those we're looking at will have either the mean is equal to some number for our null hypothesis or the proportion is equal to some number for our null hypothesis. And it'll be the same number that we have for the alternate. The alternate will always be either a less than, a greater than, or a not equal to. And we'll talk about each of those here as we do examples. Okay, so this one, however, is a less than. All right, so that's our first step. We want to state our alternate and our null hypothesis. Now we're going to do our test statistic. And our test statistic is back in your notes. Let's see. Let's find that information just so you know where to find it. Here's our test statistic for a mean, and that should look pretty familiar to you now. So let's take a look at that thing and let's plug in. All right, so we're going to have z equals our x bar is 23.994. And we want to subtract our mean, which is the mean in the null hypothesis. We're going to subtract 24 over sigma 0.13 over the square root of our sample size, which in this case is 100. Now it is wise to do this part right here in your calculator first. Now I can do the top subtraction, which is going to give us negative 0.06, but I'm going to put the bottom into my calculator, which gives me 0.013, and then I'll divide these out, and that gives negative 4.62. All right, now we're going to look that z value up on our standard norm. And let's notice that negative 4.6 is off the table. In fact, we could tell that if this kept on going downward in negative values to negative 3.5, this probability over here would be 0.0001. So, since negative 4.6 is smaller than anything on the table, what we say is that the p-value that we're looking up is less, our p-value, which is what we were looking up, is less than 0.0001. All right, now our next step is to compare the p-value to alpha. And let's think about this. Since we're looking at a mean that's less than 24, when we look at less than on a normal curve, we are looking at something being over here on the left-hand side. So we need to see if this 0.001 is smaller than alpha, and it is. It is smaller than alpha, so we reject the null hypothesis. So that's our decision. We're going to reject the null hypothesis. Now we have to say what that means. So if we're rejecting the null hypothesis, that means that we are in fact deciding that we embrace this hypothesis, that the actual weight of these packages of postgrape nuts appears to be less than 24. So here's what we say. We reject the null hypothesis. We say there is significant evidence with p-value of less than 0.001 to reject the null hypothesis. The mean weight of postgrape nuts is less than 24 ounces. So notice our steps. We came up with our alternate, usually from a statement that's in our question. Our null hypothesis is always, whether it's mean or proportions, we'll look at proportions soon, equal to whatever this is in the alternate. We do our test statistic with the data that we're given. We look up our test statistic on our standard normal chart. Now, very important, this was a less than. We looked up our amount or our proportion on our standard normal chart, and we were just able to pull it off with a less than. We'll look at what we do if it's a greater than or not equal to soon. And then we make our decision. If the p-value is less than alpha, we reject our null hypothesis, and then we state, what does it mean for us to reject the null hypothesis? It means that our alternate is true. In this case, the mean weight of postgrape nuts is less than 24 ounces.